Okay, good morning, everyone. So we are here today, okay, with a lot of representatives from different countries. We have a lot of chemistry experts over here, and we are very grateful to have them over here. And we have this conference to actually talk about rate of reaction, and we hope hopefully we can learn a lot of things from all these chemistry experts from around the world. So before we start, I would like to invite Dr. Josh, okay, to give a brief introduction about what we are going to discuss today. Maybe Dr. Josh, you can actually mention about rate of reaction. Maybe probably those viewers who are watching this show today, they might not know what is rate of reaction. So I was informed that most of our viewers, okay, they don't have any chemistry background, so they want to know more. So maybe you want to highlight more on that, Dr. Josh. Dr. Josh, I think we have technical issue, cannot hear what you're saying.
The rate of reaction can be measured by change in amount of reactants or products over time.
Okay. So we are talking about, okay, generally rate of reaction is going to be, we are going to measure the change of reactant and product over time. So maybe some of us might be still confused with what is actually the change in reactant or change in product. Maybe someone wants to elaborate on that. What kind of change that we are talking about?
Nicholas, the change in concentration of
Okay,
the
change in concentration. Interesting. So, Dr. Nicholas, so if it is going to be change of concentration over time, uh, again, if let's say, for example, if we have a sample, okay, like for example, last time when I learned chemistry, my teacher told me that whenever we look into rate of reaction, we tend to collect the volume of gas or something involving gas. So how do we actually measure rate of reaction involving gas?
Thompson, sir.
Yeah, Dr. Thompson.
So we basically measure the volume of gas produced over time.
Okay, so we do. So does it mean that if let's say, because according to Dr. Nicholas mentioned that we need to measure the concentration over time, or now we have these changes in volume of gas over time. But let's say if we have formation of gas, which one should I consider? Should I consider changes in volume of gas, or should I consider concentration? Maybe Dr. Benedict.
Giuliano, I
Okay, Dr.
think
Juliana.
only need to consider the volume.
Volume of gas. Why is that, Dr. Juliana?
I think measure volume of gas will be easier than the concentration.
Yeah, I agree as well. Okay, I agree as well. I think the collection of the gas is going to be much more easier. Okay, easier. The gases are more easier to collect compared to collecting the or looking at the changes in concentration. But apart from concentration, apart from gases collection, is there any other way to measure rate of reaction?
Geoffrey or
Okay,
the
we
change in
get
color.
Dr. Jeffrey first. Yeah, Dr. Jeffrey.
Yeah, we can see if there's a precipitate formed or there's a change in color.
Okay, precipitate that is being formed or change in color. So when we see the precipitate being formed, does it mean that we are going to measure the mass of the precipitate, Dr. Jeffrey? Maybe Dr. Arwen wants to help out on this.
Yes.
When we measure the, I think just now Dr. Jeffrey mentioned about precipitate. So are we actually going to measure the mass of the precipitate over time?
There's change in mass of
Change
the
in mass.
reaction.
Yeah. So maybe any other person, anyone have other comments on this?
Uh,
Uh, Sir.
Okay, Megan, Dr. Megan first.
Um, I think you can also measure the rates of reaction by checking the electric conductivity of
Okay.
the solution.
Okay. How do we apply the how do we measure the electrical conductivity? Because I think the concept of electrical conductivity with the rate is so far different. So how do we actually measure rate based on electrical conductivity?
Sure, sir.
Yeah.
By the formation of ions.
Okay. So formation
Solution.
of ions. So basically, yeah, I think I get it. So aqueous solution actually gives you ions. So whenever there is ions being formed, electricity can be conducted, so you can actually measure electricity. Just now, Dr. Jeffrey also mentioned about intensity of color, so maybe someone wants to actually elaborate on that.
Yeah, Geoffrey, use the colorimeter to measure the change in color.
Okay, so this one I'm confused a bit. Colorimeter, I thought that it is used to measure energy changes for Q equals to MC delta T. I might be wrong, so please actually correct me. Am my concept is wrong?
That is a different device. The colorimeter is to measure the change in color.
Oh, so there are calorimetry and colorimetry. So there's actually two different devices. I get it. So in this case now, is maybe to summarize, okay, what are the ways to measure rate of reaction? I think we mentioned about changes in mass, okay, changes in mass of product or reactant, okay, per unit time. Or we can actually measure intensity of color. We can measure electrical conductivity, and also I think Dr. Giuliano mentioned about, okay, measuring the volume of gas. Okay, so it's quite clear now. But talking about rate of reaction, um, I think we always have this concept. I think we cannot go and run away from this concept called collision theory. Can someone actually, maybe Dr. Audrey can actually highlight us or enlighten us about collision theory?
This is the theory used to predict rates of chemical reaction, and the reactants need to collide with one another. And then it has to be effective if internal energy possessed by reactants is equal to activation energy, and reactants must be oriented in a favorable manner.
Okay, okay. So basically, the collision theory tells that the reactants, they must collide. Okay, they must collide. And I remember like what Dr. Audrey mentioned about since they have to collide, there are two indications. So maybe let me be more clear about this. What are the two indications based on collision theory that we can actually use to identify whether the speed of the reaction is going to be increased? So what are the two indications? Maybe Dr. Nathan wants to help out on this.
yes, sir. Wait,
So,
can you repeat the question again?
yeah. So what are the two indications, okay, that based on the collision theory that we can use uh, to say that the rate is increased?
One way is for the frequency of collisions must increase,
Okay.
and the proportion of particles with energy must be greater than the must also be greater.
Okay, okay. So this is actually what Dr. Audrey mentioned as well. Thank you, Dr. Nathan. So I some when involves collision, since Dr. Nathan mentioned about the rate of collision must increase. Okay, so this there is something what we call as a successful and unsuccessful collision. So maybe Dr. Owen wants to help us out on this. So maybe what is successful collision and what is unsuccessful collision, Dr. Owen?
Successful collisions are when particles collide with each other and have enough energy to change into product particles.
Okay.
But unsuccessful collisions are when particles do not have enough energy and bounce off one another.
Okay, I see, I see. Thank you, Dr. Owen. So when we talk about energy, I think we've been actually talking about this energy and so on. So I think sufficient energy and so on. Is it the same as activation energy, the concept of activation energy? So maybe someone can help us out on this. What is activation energy then? Okay, Dr.
Uh,
Christopher.
Activation energy is the minimum energy required for a reaction to proceed between two particles.
Okay. So this energy that we are talking about, does it mean that what kind of energy is that? When we say minimum energy, does it mean that they have the energy or after they collide, they will have that energy?
Uh, Before the collision, both particles must have the minimum amount of energy, the activation energy.
Okay. So that is actually the minimum energy. So maybe Dr. Frederick, you want to add your point on this? What do you understand about activation energy?
No, I don't think I have to add anything. Dr. Christopher have explained it
Okay,
perfectly.
because I think last time when I had this talk, a similar talk with Dr. Gopi, he mentioned about this thing, saying that activation energy is the minimum energy that must be achieved for the reaction to be successful. So, according to my understanding, I was thinking that when two particles collide, they will create energy. So, generally, they will create energy, and those energy that is being created, okay, that is going to be of course the particles will have energy and then they will release energy, right? So those energy that is going to be released, if they reach the activation energy, which is the minimum energy, then only the reaction will proceed. So I think it's slightly different with Dr. Christopher's explanation. What's your take on this, Dr. Nicholas?
So can you repeat the question?
Okay, so in terms of my question is the activation energy, okay, that we are talking about, or the energy that we have, is it actually the energy after the collision, or is it the energy being possessed by the particle itself or by the reactant itself?
It is the energy possessed by the reactants itself.
So it's actually just the energy possessed by the reactant itself. So it means that it is happening even before the collision. So I think depends on how we look at it. Okay, depends on how we look at it. Of course, if they don't have enough energy when they collide, they are not going to have enough energy to be released. Okay, so I think the term activation energy is going to be the minimum energy required, okay, for the particles to reach, okay, so that successful collision is going to happen. So it means that it is actually the energy during the collision that will be more appropriate, yeah, more suitable. But it depends on how we look at it. Now, talking about activation energy, okay, so I think one of the uh, important question that we need to look at is going to be, can activation energy be lowered? Dr.
Uh,
Ewan?
Yes, it's possible. By adding a catalyst to the reaction, the catalyst can provide an alternate pathway which will require a lower activation energy for the reaction to occur.
I see, I see. So, so if it is going to be alternative pathway, is it right to say the activation energy can be lowered? Dr. Frederick?
well, yes, but no. The term lowering activation energy is used to make it more simple. So students like secondary and primary can understand better. But if when you reach junior college level, you'll understand a deeper explanation of it, such as providing an alternate pathway, that's what Dr. Ewan said, which requires less activation energy. That's why the term lowering activation energy is more simple to help.
Yes, yes, I agree with that. Okay, because I think when we say activation energy, when we draw the energy level graph, I think the activation energy still remains the same. So if you don't mind, I will share my screen over here so we can actually discuss a little bit on the graph. Hold on, yeah. So if you look at this graph, okay, so I think based on what um, Dr. Frederick is actually mentioning. So if this is going to be the activation energy, so if we put the catalyst, okay, the catalyst is going to create an alternative pathway with lower activation energy, but this is still the alternative pathway. Yeah. So this original pathway still remains the same. So it is not right to say the activation energy is lowered, but in simple terms, yes, it's still correct. Okay, it's going to be a new pathway is going to be created. Okay, with a lower activation energy. Okay, so that is actually what is going to happen. Yeah. So thank you for that. Okay, so in this case, okay, let's actually look at what are the in this case, like just now, I think Dr. Yewen mentioned a little bit about catalysts. Can someone actually explain more about catalysts?
Audrey, sir.
Yep.
So a catalyst creates an alternate pathway with a lower activation energy. So the internal energy, there will be a higher proportion of successful collision because the lower activation energy is needed for a successful collision.
Okay. I think later when we discuss more on this Maxwell-Boltzmann's curve, I think we can actually look at it in more detail on what Dr. Audrey is mentioning. But before that, okay, maybe since we are talking about rate of reaction, so what are the factors that will affect rate of reaction? So maybe Dr. Michelle wants to actually share something about this.
The factors affecting the rate of reaction are concentration, temperature, catalyst, pressure, and total surface area.
Okay. Okay. So can actually someone help us to actually tell how, because one of the factors mentioned by Dr. Michelle is going to be concentration. So how concentration affects rate of reaction?
Yes, sir.
Okay. Thompson first, then after that Dr. Arwan will continue. Yeah. Dr. Thompson.
Yeah, there are more molecules in a certain volume, so more collisions occur. So there's a higher chance for the molecules to collide in the right orientation.
Okay. Okay. So Dr. Arwan, you want to actually add up to it?
No, sir.
Okay. So I will actually rephrase this. So basically when you have more concentration, so you are having more particles, okay, or more reactants. So when you have more reactants, okay, the chances of collision, okay, will be more. Okay. So the chances of collision, we can actually say in proper chemistry terms, we can say the frequency of collision, okay, are going to increase. Okay, the frequency of collision rather than mentioning about chances. Frequency of collision will increase. And I think since we mentioned about successful and unsuccessful collision, so the chances of having successful collision will be more. So we can say the frequency of successful collision will be increased as well. Okay, that is going to be the concentration. So that is about concentration. The another factor is about temperature. So maybe Dr. Michael, you want to actually mention add up to this how temperature affects rate of reaction.
The particles gain more temperature, it will move more, and the frequency of collision will increase.
Okay. So maybe Dr. Elizabeth Donna, you want to add up to this?
Um, for when a temperature is rising, the average kinetic energy of the particle will move more quicker. Hence, there's more particle which has successful collisions. However, an important factor in this process is that that proportion of the proportion of successful collision increase greatly as the temperature increase. This is because there is an increase in the proportion of particle exceeding the activation energy, which can be shown in Boltzmann's distribution curve by the larger number of shaded area.
Okay, thank you. I think last time we actually discussed about these two indications with Dr. Jeffrey. Okay, Dr. Jeffrey mentioned about there are two indications, which is going to be frequency of collision and as well as the proportion of the particles exceeding the activation energy. So I think in the previous explanation, I think Dr. Arwen and Dr. Thompson mentioned about how concentration affects. I think for concentration, I think the important factor over there is more towards frequency of collision. Okay, nothing to do with the proportion of particles exceeding the activation energy because the proportion is still the same. But in temperature, okay, in when it comes to temperature, I think one, because we know that the particles are moving rapidly, they are moving at a higher energy. So of course, it satisfies one of the indication, which is going to be frequency of collision is increasing. But and then also Dr. Elizabeth is mentioning about the proportion of the particles also increasing. So I think the proportion we can actually show this better. I think the one that Dr. Audrey also mentioned earlier, something to do with the Maxwell-Boltzmann's distribution curve. So I think when we look into that Maxwell-Boltzmann's distribution curve, we can actually look into detail. But before we go into those, okay, so maybe can someone help us? Maybe Dr. Jasmine can actually help us to tell us about what is actually meant by Boltzmann's distribution curve.
Maxwell-Boltzmann distribution curve is the probability distribution for describing energies of particles.
Okay, so the every particles they have their own energy. So can I check whether Dr. Catherine is here? Dr. Catherine, do you have any comment on this?
Sir, Catherine cannot go in the room.
Okay. So Dr. Catherine is not available. So maybe we can actually check with Dr. Wilson. Dr. Wilson, maybe you want to actually add up to this. What do you understand about Maxwell-Boltzmann's distribution curve? Maybe you can explain more.
The probability distribution used for describing speeds of various particles within a stationary container at a specific temperature. So the y-axis is used for representing number of moles, while the x-axis is used for representing temperature.
Okay, to make it clear, maybe I can show everyone this diagram. Okay, so this is actually based on what being said by Dr. Wilson. Dr. Wilson mentioned about the y axis is going to be your number of molecules, and then your x-axis is going to be the molecular energy. So we have the graph and so on. So maybe can someone actually help us to tell us about the shape of the Maxwell-Boltzmann's distribution? Maybe Dr. Josh, you want to actually help us in here?
The higher the temperature, the height of the curve will be shorter and it will be scaled to the right. Thus, the most probable energy will be increased. The rate of reaction will also increase because there's a higher frequency of collision and there are a bigger proportion of particles that have a greater energy than the activation energy.
Okay. So the curve, is it actually, I do see the curve is actually kind of, there are two curves over here. One is the dotted, another one is the normal curve. So which one is going to be higher temperature over here? So maybe Dr. Michael want to mention about this?
The normal curve is the one with the higher temperature.
Okay. So why, I thought that whenever we have higher temperature and so on, the peak should be higher, but here I think the peak is lower. Can you actually explain about that? Maybe someone else can actually help Dr. Michael as well. I think he's not.
Can I explain?
Yeah, Dr. Benedict, hold on. Yeah, Dr. Benedict.
The peak is usually defined as the most probable temperature, and as